All right, here we go. This is going to be the homework help video for the inverse variation worksheet. Let's jump right into it. Describe how you determine if a function is a direct variation. So I want to say a few things for this. First off is that if the equation is given to you, or if the function is given as an equation, so if the function is an equation that can be rearranged into the form y equals k times x, or the other way that it can show up is if you divide x to both sides, and let me zoom this out just a tiny bit. Let's go 100%. Okay, or we divide x from both sides, y over x equals k. So if the function is an equation that can be arranged into one of those forms, we know it's direct variation. If the function is a table, then in direct variation, we should try dividing pairs of x and y and see if we get the same number k over and over. All right, so if the function is an equation that can be arranged into the form y equals k times x or y over x equals k, it is direct variation. If the function is a table, then try dividing the pairs of x and y and see if we get the same number k over and over. And k is always y divided by x. If you do x divided by y and it's constant, well, it's still direct. But to get the actual number k, we always want to do y over x. Inverse variation, very similar. We'll say an equation is an inverse variation if it can be rearranged into x times y equals k, or the other way that it can show up is if we divide x by both sides, y equals k over x. So if you do your inverse operations and you switch it around and you can get into one of these forms, then you've got direct or inverse variation. If you are dealing with a table or ordered pairs, each pair should multiply to be the same value. So one way to kind of keep that straight in your head is to think divide is direct variation. They both start with a D, and so then hopefully you can remember all the different types. Okay, so moving on, problem 3 through 8, we're asked to state if the problem is inverse or direct variation, and then state the constant of variation. So 3 is already in this form here, so we know this is direct, and we know that k equals 7. Number 4, we don't see addition in any of these forms, and no matter what we do, we could subtract x from both sides, we could subtract y from both sides. We'll never be able to get it into one of these forms that we've got up above, so this is just going to be neither. There's our forms. There, and there. So this is neither, therefore it doesn't have a constant of variation, or k. This one here looks just like this, so it is direct, and k equals 9. This one here looks just like this. This is inverse, and k equals 12. This one here looks like this. This is inverse with k equal to 4. And then this one here, this is a table. So kind of hard to tell if it's direct or indirect, especially when it's so out of order in both columns. So what we could do is we could just try multiplying, and then if that doesn't work, dividing each pair to see if we get a constant. So if I multiply these, I get 32. If I multiply these, I get 32. If I multiply these, I get 32. So every time I multiply, I get the same number. So that tells me that, yes, this is one of the types. Specifically, it's inverse variation, and our k equals 32. So this is inverse, k equals 32. All right, let's just try one of these here, 9 or 10. 10 looks maybe a little bit more tricky. It tells you that this is inverse variation, so we know we're dealing with this equation here. X times y equals k. And when y is equal to 100, x is equal to 2.5, so we can use that to figure out our k value. 2.5 times 100 equals k. K equals 250. So find x when y is equal to 25. So x times y equals 250. Let's plug in 25 for y. X times 25 equals 250. Divide both sides by 25. And we'll get that x equals 10. All right, onto the back side. We are told here the heart rate and lifespans of most mammals are inversely related. Cats, for example, live about 15.2 years and have an average heart rate of 126 beats per minute. So we'll just pick heart rate to be x and lifespan to be y. If they're inversely related, then x times y needs to equal some value k. Let's plug in the values we've got. So 126 for x, 15.2 for y. What do we get when we multiply those? 126 times 15.2, we get 1,915.2. The unit for this is kind of tricky. It would be like beat years per minute, but it's just our constant k. We'll just call it k. The hamster has a heart rate, so that's our x. So x equals 364. We know k is constant, so 364 times some unknown lifespan y equals this constant here, 19.2. We divide both sides by 634, and we get 3.02 years, which is actually about what a hamster lives. Elephants, live for about 70 years, so y equals 70. So x times 70 equals 1915.2. We'll divide both sides by 70. So again, we're just dividing our constant, and we get about 27 beats per minute, approximately 27 beats per minute. Number 12, 2 gears used to operate a machine. Gear A has 60 teeth and gear B has 45 teeth. The speed at which you turn gear A is 5,400 revolutions per minute. The number of teeth and speed, so the teeth and speed are inversely related. We know inverse, so we'll say teeth is x, speed is y. There's some unknown k, but when we turn gear A has 60, so x equals 60 in gear A. And then the speed y is 5,400. So we're going to multiply those. 60 times 5,400. We get this big constant variation. 324,000. And you could think of that as teeth per minute, because this is 60 teeth per revolution. This is revolutions per minute. So 60 teeth per minute are going around this machine. And so what speed will gear B turn? Well, gear B has even fewer teeth, so we'll have to turn even faster. So in gear B, X is equal to 45. 45 times some Y equals our K value of 324,000. I'm just going to take that number, divide it by 45 to get that it's going to spin at 72,000 revolutions per minute. These are actually, this would be pretty fast for a car's gears to be turning, but not unheard of. Different cars have different red lines. Let's just do one more, something with direct variation. The amount of water that's leaked from a faucet varies directly with time. In 2 hours, 10 gallons of water leak. So if it's direct variation, the water that is leaked, we'll call that X. Time will be Y, and we know that Y over X equals some constant K. And so water that's leaked is 10 gallons. 2 hours. So our constant is 1/5, which means 1/5 of a gallon is leaking per hour. So the constant variation is 1/5. How much water leaks in 100 hours? So now we've got Y over 100 equals 1/5. Multiply both sides by 100, and we'll get 20 gallons. And then how long does it take for 100 gallons to leak? 100 divided by some X equals 1/5. Here I could cross multiply, and I would get 500 hours. All right. Yeah, and again, another reasonable, the units in this problem are reasonable. All right, hopefully that helps with your homework. And I will see you next time. Adios.